Welcome to week 9 of physical oceanography. I hope you're all having a good weekend after your midterm. We started this semester by asking the question, why are the oceans in perpetual motion? And we started to answer that question by looking at the fact that waves transfer energy across the oceans. And so we see motion with the waves. And then we looked at a very long wavelength wave, tides, which are governed by the gravitational attraction of the moon and the sun. And those cause motion in the oceans as well. And then we also thought about the fact that the Earth's own gravity is also pulling down on the oceans. And so because of that, we assumed that the oceans are in hydrostatic balance. And so there must be a force that's acting upward. And that is the vertical pressure gradient force. And then we also looked at the fact that this Earth is constantly rotating. And because it's rotating, that generates a Coriolis force. And we could see that when we looked at what we can see right here behind me, a lot of little motion that ends up just be determined by the latitude that the water parcel might be at. As long as it has some initial inertia, some motion, then it will move in these inertial currents due to the fact that there is a Coriolis force. Now, this week, we're going to look very specifically at two other forces that govern the ocean. We're going to start by looking at friction and look at how friction starts the ocean in motion. We started to see that a little bit with waves, and now we'll look more specifically at that force of friction. And then we'll look at how the balance between friction and the Coriolis force leads to what we call EkmanTransport. And that's what's actually responsible for coastal upwelling as well as equatorial upwelling. Then we'll be looking at another force, the horizontal pressure gradient force, and we'll see how the balance between the horizontal pressure gradient force and Coriolis leads to what is known as geostrophy. And we end up with geostrophic currents in the ocean, or quasi-geostrophic currents in the ocean. We will be meeting on Monday at 3 p.m. Prior to that, I want you to read, at least look through two sections. One is from Noss and Garfield on chapter 5 on friction, and the other is from the Open University Ocean Circulation, section 3.1 on wind stress. Then we'll be meeting again on Wednesday, and we'll be going over the horizontal pressure gradient force and see how the balance between the horizontal pressure gradient force and Coriolis can lead to geostrophy. Then we'll be meeting up at the lab on Thursday, and we'll be actually looking at how we can see geostrophy in action, as well as generate some Ekman layers. And then we'll be meeting again on Friday at 3 o'clock to continue to look more closely at that horizontal pressure gradient force and look at how we can have barotropic and baroclinic situations in the ocean, and we'll understand what those are. All right, looking forward to seeing you all Monday at 3 o'clock to talk about friction and EkmanTransport.